You remember from year 10, objects are similar if they're what? If they're the same shape. Well done. If they're the same shape, they are similar. But they are different in size. Because if they were the same shape and size, they'd be congruent, right? I see a lot of people copying. That's nice, but it's in black. You don't need to get that. I'm just reminding you what similar is. They're the same shape but different size. So what we're dealing with here is enlargements and shrinking. If, for example, these two cubes here, I'll scroll it up to the top. This one's 2 centimeters by 2 centimeters by 2 centimeters. This cube is 4 by 4 by 4. Shh. What have I done with all those dimensions?
Doubled them.
Doubled. Therefore, the scale factor is 2. Everything has been multiplied by 2. All right? If objects are similar, we have a shortcut to find the area and volume of the objects as long as we know the scale factor. If you did that baby DI last year, you remember we hammered this because you're supposed to find the area and volume of the baby like 8 times. You're not doing it multiple times this time. Okay, you're just doing it once for your DI, but you have to be aware of this formula. So can you get these formula down, please? The new area is going to be equal to k squared times by the old area. The new volume is equal to k cubed times by the old volume. In both formula, you're using and finding k, which is the scale factor. If you ever need to work out the scale factor, k is equal to the new measurement over the old measurement. Get that down, please. We're going to use it today. What's up? So your relief teacher next Thursday, I'll give them a pile of grid paper to write your one-sided A4 handwritten note sheet. I'll also give you grid paper on the Tuesday as well when I'm here. But you do your revision, yeah? And I'm telling you, that practice test is longer than the real thing. If I recorded that practice test and it took 40 minutes while explaining everything, the real test shouldn't be that difficult. Right? Okay, would you like me to read it up? In both formulae, K is the scale factor. In both formulae, K is the scale factor applied to the old object to get the new object. Now that second line, if you need to work out the scale factor, you can use K is equal to the new measurement divided by the old measurement. And scroll down so you can, faster people can get the example. What's happened with the pyramids? I've got a small one and a big one. A to B, I've enlarged it. The small pyramid, I know, has an area of 40 square centimeters. It's got a volume of 15 cubic centimeters. And we want to use these formula to find the surface area of B and the volume of B. Would I be able to find the surface area of this pyramid given this information, just the 8? If I used the surface area steps that I've given you for finding a pyramid, would I actually be up ignoring the new formula today? Could I find the surface area of this? Do I know how tall it is?
Nope.
No, I can't find the surface area using the normal method that you've had before. The only way I can find the surface area is because I know that this big one is similar to the small one, and I know that. Anyone game to tell me what the scale factor is? It used to be 2 wide. Now it's 4. Now it's 8 wide. So the scale factor is 4. How do I? If it wasn't that easy, I could do new measurement 8 over old 2. So it got quadrupled. All the measurements got quadrupled. But that doesn't mean the surface area was quadrupled. Okay? If all you did was go 40 times by 4, you would be wrong. Okay? Because it's 4 squared times by the old area. So using this formula, new area, surface area of B is going to be K squared times by the old area of 40, which is equal to 4 squared times 40, which is equal to 16 times 40, which is equal to
640.
16 times 40, 640 square centimeters. I can just drop the mic and not teach it. I'd rather get paid for doing nothing, because it seems like other teachers here do that too. Right? Just go on their Facebook or whatever. I'd like to teach. Yeah? If you got something to add, you can go up here. What's the difference if I'm finding the volume? There is only one difference in that whole formula if I'm dealing with volume. What do I do with K this time? I cube it instead. So V of B is equal to K cubed times by, it's not 40 anymore because the volume was 15. So it's K cubed times 15 equals K, 4 to the power of 3 times 15. 4 times 4, 16. Times 4, 64 times 15. 64 times 15 equals 960 cubic centimeters. Can you get that example down, please? And then I've got one more to do, and then you can talk. I've checked a lot of people's maths already. I want to check more. Yes? I got a shotgun.
I didn't do it more. Oops.
If you can see these notes, this in red, some of the stuff on your timeline, it asks you to use this formula in reverse. Okay? You'll see the example that I show. No, you don't. I'm just explaining why this new one is different. Look at this situation. We know that these cones are similar. That formula that I gave you told you what the volume was. Do I already know what the volume is? I know what happened with the volume. It started at 270 cubic meters and it went down, so it shrank. But this question is asking you to work out what's the scale factor. I want to know what the measurement was. Before I knew the measurement, I knew it went from 2 to 8. Do I know that right now? No, I don't know what the measurement is. So how do we use this formula in reverse to find this information? It's volume. Do we have a volume formula? What was the volume formula? Can you remind me? New V equals K cubed times by old V. Let's use that. Put what we know in. It used to be 270. It used to be 270 times by K cubed. What is the new volume? It shrank down to 80. And now I know no one likes algebra, but we use algebra here because I want to get K by itself. What's the opposite of timesing something by 270? So if I divide both sides by 270, what am I going to be left with? I'm going to be left with K cubed is equal to 80 over 270. Can that 80 over 270, can that cancel down at all? Are both of those numbers divisible by 10? Because there's a 0 on it. So that cancels down to 8 over 27 is equal to k cubed. You could use cube root on your calculator, right? But we can think about it. Is there a number that I can times by itself 3 times? Is there a number I can cube to get 8? What number can I times by itself 3 times to get 8? Yep. 2. So k is going to be 2 over... Is there a number I can times by itself 3 times to get 27? 3. So k is going to be 2 over 3. If you're not confident with that, okay, if you can't do that in your head, that's fine. You would just go k is equal to the cube root. There's a button on your calculator, 8 over 27, and you'll get exactly the same answer. K is 2 over 3, all right? So what is that saying to us? The scale factor is 2/3. It wasn't doubled. It's 2/3 of what it was before. So how could I find what x is? What did the measurement used to be? It used to be 10 meters. How do I find 2/3 of 10 meters? How do I find half of 10 meters? What would I times 10 by to get half of it? Good. Is 2/3 a fraction? Mm-hmm. I just times it. So I go, okay, 10 times by 2/3. Yep. What's the question?
Is k like
6.67 meters is x. Okay? I'll stop the recording.